what is the weather like in New York today. Okay, New York weather today. Now it's try to call the tool. Okay, now it gave us the location. Now it gave us, okay, today New York weather is overcast with a temperature of 20. What is the population of USA as per today? Let's check. Maybe it's gonna reach something. So, okay, current population of USA 2024. Now it's interesting. Now, and it gives us the link. It's very interesting. And basically here it gives us the result live. Hello everyone, so in today's video we're going to be taking a look at a very interesting framework for building AI agents. Through the past 2 years I've been building AI agents using Python, and then I moved to LangChain, which is basically a framework for building AI agents. It basically wraps a lot of functionalities, different interfaces with language models, and basically it offers a wide range of features related to building AI agents with Python. In this video, we're going to be taking a look at LangGraph. So LangGraph is basically an updated version of LangChain, aiming at making building agents more flexible. So basically, adjusting LangChain agent executor was a little bit tough, and you didn't basically get full flexibility on how agent executes at runtime. So basically, you had the large language model, you had your prompt, you had the list of tools, but in runtime, like during runtime, you didn't have full control over how the agent actually interacts with the environment, interacts with the tools. Then basically LangGraph came with this promise to make building agents more, or what they call cognitive architecture, for any task easier, using the notion of a graph. A subtask or a sub-agent in your workflow is going to be like a node in the graph, and this node can be anything, literally from Python function to basically a large language model call, tool nodes as well. Also, what I like about it is that it is actually a framework for debugging your agent execution. Previously with LangChain, like debugging was a little bit difficulty, because what you needed to do is you needed to basically stream the intermediate steps. And even though you had the ability to see the intermediate steps, it was particularly difficult to adjust the workflow at certain points of execution. So, for example, you would have a chain, and you would have multiple chains, but then you want, for example, to tweak a certain part of your workflow. It was difficult to do so with LangChain alone, and you would basically create custom classes in Python to do so. And now basically, like this simplified this approach for you. You can break down your workflow into nodes. At the same time, you can basically add or remove nodes and functionalities from your workflow. So yeah, again, the debugging, you have like everything is streamed in real time. Your tests and the basically the user experience. It's kind of like an IDE complementary for building AI agent. So basically that's a quick introduction to LangGraph. And also in this video, we're going to be taking a look at LangGraph Engineer. So the LangGraph Engineer is a project built with LangGraph, aiming at basically building AI agents using a LangGraph agent. So this AI agent will help you build AI agents, basically through just communication with it. So you just tell it what agent you want to build in LangGraph, and then it's gonna give you the Python code for building this workflow that you're looking. So we're gonna basically take a closer look at it, and we're gonna build an AI agent with the LangGraph Engineer. I think let's get started. So the first thing that you need to do, we need to install the LangGraph Studio. It's not a mandatory step, but it's the step that's gonna basically help us to view our graphs and view the workflow execution in real time, and it will help us debug our code. So the first thing we need is to install LangGraph Studio. So I already have the application open, and also what we need is you need first to install Docker as well. So for installing Docker, basically here we have the instructions for Linux, Mac OS, Windows, and you're going to go ahead and install Docker. I have already done that. So once you have Docker, once you have LangGraph Studio application installed, now you can get started with the LangGraph Engineer. So what I have done is I have cloned this repository already into my local machine, and basically all I need to do is I need to go to the LangGraph Studio, and I need to open the project. So So the LangGraph Engineer, I go to that folder, I select that folder, and then it's going to build the Docker container for the LangGraph Engineer. First install Docker. If you do not have it, you go to the Docker engine on docker.com, and you install Docker. Depending for you, it's for Linux, Mac OS, or Windows. For me, it's Mac OS, and I already have the Docker desktop basically application. So yeah, the next step is you install the LangGraph Studio. To download the LangGraph Studio, you just go to the GitHub repository of LangGraph Studio, and you basically download the file. And once you download it and you install it, you would have something like this. Because I have already had cloned this GitHub repository in my local machine, and I basically just like opened it in LangGraph Studio, here's what we have. So we have basically our AI agent as a graph. Let me just like explain briefly what this graph does. So at the start of the workflow, it's going to accept the input, which is basically a user message. So this user message then goes to, which is basically the description of the AI agent that we would like to build with LangGraph. After it takes our input, it's going to start gathering the requirements from the user. So it's going to basically go back and forth asking you questions to gain understanding about the workflow and about the agent that we'd like to build. Once it has a good idea of what it should build, it will start drafting an answer, which is basically a Python script that basically represents our AI agent. After it builds it with Python, it's gonna go through multiple checks. The first one is the syntax checking. So it's gonna be checking the syntax of the code for any mistakes or errors in the code. And once it has an idea that this code actually can compile, can work, it also passes it to a critique node. So the critique node will take a look at the requirements that has been gathered from this node. It will take a look at our query, and then it will try to basically criticize the answer, the Python code that has been generated by this node, by the draft answer node. So this is a workflow. After it has like some confidence with the answer, it's going to return the answer, which is basically just a Python code that we're going to paste then in our LangGraph project, and we're going to run it. Let's now try to build something simple. We're going to be building an agent using one of the most well-known frameworks for building AI agents, and one that has shown significant improvement over few-shot prompting, for example, which is the React framework, which is energizing reasoning and acting in language models. So the main idea of this, given a certain task, the agent is going to break the task into subtasks. So let me show you. So this is how the React framework works in practice. So basically this is the execution, this is the runtime of the AI agent that we have built. So here you have the prompt that you give to the AI, to the language model, and here you have the language model itself. You have the output parser, which can be like some structured output, and here you have the agent action. So as we know, as we said, the agent will have a set of tools that is going to be using to interact with the environment. These tools can be API calls, they can be like function calls, like just Python functions. So they can be basically anything that we would like to have as tools to give access to the agent during runtime. So this is basically, here we have the set of tools, and here we have the agent action. So basically here we're going to have a loop, and this loop begins with reasoning. So we have, again, as I said, we have React, we have reasoning, and we have acting. So the reasoning begins with the model trying to break the task into subtasks. So for example, let's say we want to book a flight to go somewhere. So the first step to book a flight is actually we need to search for flights. So here we're going to have a tool for searching for flights, and this tool will basically have access to some flight search API, and it's going to return to us a set of flights that match our desired destination. So this is the first step, for example. The other subtask is to actually compare prices and see which flight actually makes the most sense for us, and which is basically the flight selection as well. So flight comparison and selection, price comparison and selections. After that, there might be another tool or another step, which is basically just making the booking. So and I think we just like make the booking and finalize basically the flight bookings. So basically booking a flight will be broken down into smaller subtasks that the agent will gonna attempt to solve one by one. So yeah, after it made this plan, after it made this reasoning and plan, it's going to start the execution. So first thing, it's according to the plan. For example, it was search for flight. It's going to select the search for flight tool and it's going to run that tool. So we can see here it's going to run the tool, and then after running the tool, it's going to return the flights, and it's going to save them in intermediate steps. And these intermediate steps are visible by the agent, and the agent basically can check the results and it can take action based on this result. So for example, if everything was returned correctly, the destination was correct, everything was correct, it's going to try then to make some comparison. So the user will say, oh, okay, compare this, or we have like these set of flights, and let's try to compare them. So it's gonna invoke the comparison tool. And then after that, it's gonna give, for example, the best option. So this all runs in a loop. And then after that, if the selection was finalized, then we're gonna go with the make a booking tool, or like book the flight tool. And this execution is gonna go in a loop until the agent decides that, oh, okay, the task has been finished, or we need something from the user, so we need to return some answer to the user. So the agent will decide, either I'm gonna use some tools from the toolbox, or I'm gonna just return the answer to the user. So this is basically how the React framework works. And basically, how does this look like in LangGraph? The graph looks like this. So we have the agent, and at every step, the agent has two options: either to end and give a response back to the user, or it's going to try to continue to execute one of the tools. So for example, if the agent found out that, okay, the booking was done, everything was done, it's going to decide to return back to the user. Or for example, in other cases, it might need some information. For example, okay, you want to book a flight, where you want to go. So this is also a decision to go back to the user. Otherwise, for example, it has all the enough information that it needs, it will decide to call one of the tools. Once it decides to call one of the tools, the result of running the tool will go back to the agent. So this loop is gonna continue until the agent actually makes a decision to go back to the user, ask a question, or give the response. And then it's just like this loop goes, finish, go to the user, or the user will say, and the user will say something, will go from the start. So it's a very simple concept, very simple graph, but it's actually very powerful. So we're gonna attempt to implement something like this, this graph, using the LangGraph Engineer. So we're not gonna write any code. We're gonna let LangGraph Engineer do the work for us, and then we're gonna check the code. We're gonna see whether it actually runs, or not. So I want to build. Do you know what React framework is? So let's see if it actually has React framework is in the context of building AI agents. Let's check if it actually knows what that is. Yes, the React framework is a method for building AI agents that combine reasoning and acting. It allows agents to perform complex tasks by reasoning through a problem, blah, blah, blah. So in the context of building AI agents, React can be used for decision making. Okay, so it knows what it is. Okay, great. Okay, great. Now I want to build an AI agent that has access to internet. So I want to have a tool node for searching the internet, and the main node for making decision whether to call in that tool. It's not the best description, but I think I gave it the idea. So I want to build basically something like this, where basically this node actually searches the internet. So let's see. What should happen after the main node makes a decision? Are there any other nodes or actions that should be taken based on the decisions made by the main tool? By the main node? No. if the node, if the main node decides that it doesn't need to make a tool call, the tool node just return an answer for the user. Understood. So the main node, the node makes so let's see. So actually it decided that it's gonna draft the answer. So the graph consists of two nodes. One main node. This node decides whether to call a tool node for searching or directly returns an answer to the user. Tool node. This node is used for searching the internet. This follows the start node. The main node decides to search the internet. It calls the tool node. The main node decides not to search the internet. It returns the to the user. So yeah, let's see. So yeah, we can see here that yeah, one thing to note is that it actually uses I think GPT-4o for writing this. Yeah, so it uses either GPT-4o or Claude 3.5 Sonnet. So yeah, let's see. So it actually gave us this code. And now we need to see accepted. So the graph has two nodes. Okay, let's check the flow. Actually, we can just copy this code and we can take to the we can take it to some yeah. So here actually I have a LangGraph example. So also you can go. I'm gonna link this this repo in description. So LangGraph example. So this one basically has just like a simple example to what we want to do. It's like it's basically does the same thing. So basically I'm just gonna use this as a like a skeleton for what we're building here. So the agent that we want, let's see, so basically I copied this code, which is the output of the LangGraph Engineer, and I want to put it in the agent node. So I'm just gonna remove everything here. I'm gonna paste the code. So let's see. So it has this tool search the internet, which basically searches for the result. And here we have that, oh, okay, search the internet function. Here we have the tool call, search the internet with a query. That's nice. We have main node, tool node. Let's see the edges. So the edges is either search the tool or finish. And the tool, basically from the tool, it goes to the end. So this is actually fine. However, we wanted to basically return to the user, so or return the, like, we want the result of the tool call to go back to the main node. I want the output of the tool call to go back to the main node. Also, for searching the internet, let's use Davily search results. Instead. So let's see if it can make these changes. Submit. Okay. It's modifying the graph now. So let's see now. So here we have the agent. Okay. Now what we need to do is we need Davily search. Okay, Davily search result for query. Okay, so this is acceptable, I think, for now. It doesn't have the business logic. So now let's try to run this. Let's just close this one. And let's basically just open a new one. Go to project settings. So you can see that now we need to specify the path to the file that has the agent code, like the main workflow of the agent, which is basically the agent underscore. So I'm gonna specify that agent underscore in my case, and the name of the graph here. Basically, the name of the graph is app. So app, and I think I do not need the example invocation. And I think that's all. So let's restart, save and restart. Now let's see. basically project settings, save and restart. So okay, so now at the beginning it's trying to pull the LangGraph API Docker container from the repositories, and then it's basically trying to compile the project. So now let's see. So now we have an error. So the error is that the requirements did not complete successfully with exit codes. Actually, let me just filter out the packages that I do not need. So I do not need Google API Python client. I do not need Google authentication. I do not need Google. Let me actually, yeah. So I do not need this one. I do not need Slack SDK. I do not need this. I don't need this. The only thing I need, I guess, is Davily Python, LangGraph. These ones. These are the only ones that I need. So yeah, let's now it's trying again to build it. So let's check. Resolving. Postgres MySQL. Yeah. So now it's built this. So now we have the main node, tool node, and the end node. So it actually built the graph pretty much as we expected, as we wanted. So basically we wanted to build something like this, and it actually had done so. And now let's actually try to say hello. How is the weather today in New York, let's say. Okay, so human is not subscriptable. Let's try to debug it. So instead of content, we need actually to, so it's not a dictionary, it's an object. So we need to just like extract the content like this instead. So dot content. Another important thing is that this doesn't have any large language model node. So what I'm gonna do instead, I'm gonna go here and I'm gonna basically find basically the code to be able to answer questions. So I'm gonna just like take something very simple from here, which is from the example that I showed you earlier, and I'm trying to put it in the main node. So the main node, so the model is gonna be, let's just use from Lang chain OpenAI, import chat OpenAI. So we're gonna just be using the OpenAI, our chat OpenAI temperature 0 model GPT-4o mini. Let's say use the mini model, and basically what we're gonna do, so the system prompt is very simple, just be a helpful assistant. So that's the system prompt, and basically in the main node we're gonna be just using the call model function. So the call model function, or let's just be using that as our main node, and basically, so the messages, the state messages, the role is a system prompt. So now we're trying to call it, and then we invoke it. And then in the invoke, we need also to tell the model that it has access to the tool. So this is also something that the model didn't do. So let's try to do that now together. So yeah, so we're gonna remove actually this decision from the state, and we're gonna add a tool node. We're gonna actually just be using this tool for search. So okay, so here we're gonna just be using the search, Davily search results, which is search the internet. I'm gonna do just like tool node. So let's check now. Yeah, so let's check the graph now. So I'm gonna retry. So yeah, the changes I made is that I basically replaced the tool node that I had with a pre-built tool node from LangGraph, and basically just the main node I just replaced it also with basically a language model call that will basically decide whether to call the tool or not. So here it's telling me that I have an error here, which is complaining now about the decision. So I think we do not need this anymore. So now actually we need to change this, because now we do not have decision in our state anymore. So what we're gonna do is that we're gonna replace this, and we're gonna basically return search if the last message is a tool call. Tool calls basically else return answer. So let's do it like this. Yeah, So basically the state has two calls, then it's we go to the search, otherwise we go to the answer. If we go to the search, we go to the tool node. If not, we just go to we just end the execution. So now let's retry. Check. So yeah, as we can see, we did some debugging to the output of the LangGraph Engineer. However, like it gave us the schema, and we just needed to debug it, not like to not write it from scratch. That's the only thing. So now, okay, it will try. Now we have the main node. It try either to search or to answer. So now let's see again, what is the weather like in New York today? Okay, New York weather today. Now it's trying to call a tool. Okay, now it gave us the location. Now it gave us, okay, today New York weather is overcast with a temperature of 20. The wind is, you can click it here. So it's interesting. So it gave us actually the weather API. So it reached the weather API, which is interesting. So yeah, okay. This is really interesting. So it gave us the result. Now let's see something else, like okay, hello, how are you? So for this example, for example, for this query, it shouldn't actually call the tool, it shouldn't search the internet, it just should reply to me. So let's check. Now it's in the main node. Now it just ended. I'm just a program, I don't have feelings, so that's okay. And now let's try to ask some question that again needs some information from the internet. So what is the population of USA as per today? Let's check. Maybe it's gonna reach something. So okay, current population of USA 2024. Now it's okay. The current population of is 345 million. Interesting. Now, and it gives us the link. It's very interesting. And basically here it gives us the result live. That's what we wanted to build. So now we have a tool where basically it searches to have access to internet, and it actually can basically search anything we want from the internet, and then we can basically expand this workflow and have other things in it as well to make it to build on top of it. So now we have, for example, we have the agent has access to internet. Now we can do a lot of stuff with it, and basically build our applications around this agent. So that was everything I wanted to show you in the video. So this is a conclusion to wrap up what we've done. So we basically first we introduced basically we had a little bit of introduction about LangGraph. We built an agent using the LangGraph Engineer. So the LangGraph Engineer actually just built the foundation for us, and then we just built on top of it and basically corrected some bugs that it had, and basically we were able to get a working version of this product, or of this like simple AI agent. And I think it could be very useful. We also see here like how many tokens it uses, how much time it took, the search took, and basically here it shows us, it also returns us the link to the results. So this is really helpful. So thank you so much for watching, and see you in the next video. Bye bye.